Good day. In this lecture video, I'm going to discuss solution to an additional problem from the sample problem number 3 in lecture 4 about EMF, terminal resistance, and terminal voltage. So again, a voltmeter connected across the terminals of a battery gives a reading of 12 volts. However, when an external resistance of 10 ohms is connected across its terminals, the voltmeter gives a new reading of 11.5 volts. Determine letter A, the power dissipated in the battery, and letter B, the power delivered to the load. So, as usual, here are the given parameters and the rough sketch of the situation. And our target variables are the power dissipated in the battery for letter A, and then the power delivered to the load for letter B. Okay? Take note that both these unknowns are not the same. Okay? So before that, before solving the problem, here is a short discussion about the relevant concepts needed to solve this problem. So the power dissipated in the battery is due to its internal resistance. So the power dissipated in the battery is equal to the current squared multiplied by its internal resistance. Okay? The power delivered to the load for letter B is the net electrical power output of the source. Or this is a more familiar formula for you. When a battery is supplying power in the circuit, then the power supplied or delivered to the load is equal to the EMF times the current minus the current squared times the internal resistance. Okay? So before executing our solution, so this term, epsilon times I, so in a battery in particular, so this represents the rate at which energy is converted or chemical energy is converted to electrical energy. Okay? So part of which will be delivered to the load, and the other part will be dissipated in the internal resistance. So to execute our solution for letter A, first we need to solve for the current. Okay? Again, based from this circuit. Okay? So the current is equal to the EMF of the battery divided by the sum of the internal and external resistances. Okay? So I is 1.15 amperes. And then we can now substitute in this equation. Okay? So the power dissipated in the battery, I squared R. So, and then, so the current is 1.15 amperes multiplied by internal resistance as previously obtained, 0.4348 ohm. So the power dissipated in the battery is equal to 0.575 watt. Okay? Then for letter B, so the power delivered to the load, okay, we can just substitute the values. Okay, so we have 12 volts, the EMF, or the open circuit voltage of the battery times the current minus the current squared times the internal resistance. So the power delivered to the load is 13.225 watts. Okay? So in this example, the sample problem, the power delivered to the load, letter B, can also be solved in different ways. Okay? So first, the power delivered to the load, looking at the load side, is equal to the terminal voltage, okay, 11.5 multiplied by I, or 1.15 amperes. And it's also equal to the current squared times the external resistance, since the net electrical power output of the source will be supplied to the external resistance. Okay? The load power can also be solved using this formula where we multiply the current squared times the external resistance. And finally, can also be obtained by squaring the terminal voltage divided by the external resistance. So I leave it up to you to verify that the answer for these three expressions will be equal to 13.225 watt. So this ends the solution to the additional problem.